So things are looking better. However, Ed, you want to give them the however?
I think you need to use long division.
Yeah. Why though?
Because the degree of the numerator is higher than that of the denominator.
All right. What's the degree of a polynomial? How do you find the degree of the polynomial?
Highest exponent.
The highest power, right? Would you agree that the degree of the numerator is higher than the degree of the denominator? And if you went back and looked at every other problem we've done, that's not been true. Okay? So, I'm going to make it a little bit stronger even. I'm going to make it, if the degree is the same, I want to do long division. Wouldn't you, Ed? So I'm going to say,
Well, the only problem is they haven't, in 99, we don't keep that long division at the present time.
you have what?
In Math 99, we do not cover the long division.
Oh. I know, that's why I'm covering it now. And besides that, Jake would have forgot it.
Last time I did that was an algebra.
Rule 2. If the degree of the numerator is higher than the degree of the denominator, then continue as before. Well,
What I'm trying to underline it.
Degree is higher or equal to, don't you have to do long division?
watch and see. Watch and see if I've got it right. Otherwise, do long division first. That says, if the highest exponent in the problem is in the bottom, just keep on going like you always have. That's what it says. If it's a tie, or if the highest exponent's in the top, do long division.
Isn't the top the numerator? Isn't the top the numerator?
Yeah, because what that's saying is if the top is higher, then continue.
I was gonna write it, the issue is equal. Some calculus teachers tell you just if it's greater. I'm telling you, even if it's equal, it's worth it to you. So let's change it to denominator. Okay? Barris?
Is that long division the same as synthetic division, or is that
Yes.
the same?
If you want to do synthetic division, by all means. I'm not going to show them that. I'm going to show them long division because I can make long division look easy. here's a review on long division. Would you say that 2 over 3 really means 2 divided by 3? Isn't that how you get a decimal answer? Yes or no? Okay, so this is what long division is. Long division says that I want x squared. Let me leave myself some room.
It's only supposed to seem like divide sign like that.
I'm gonna get back to you, Spencer.
Oh, it's not close.
I have to concentrate to copy this right, and it still might not. Isn't that the same as 2 divided by 3? Now, always notice, always use only the first term. So what I'm saying is, I'm going to look at this term and this term. What do I have to multiply this term by in order to get that term?
2x.
2x. Everybody agree? 2x. In long division, as you learned how to do it in the 3rd grade, what's the next thing you do?
You put whatever, and then you subtract by
You multiply the 2x
everything.
and then you subtract, right? That's what we're going to do. Remember, you are subtracting. So 2x minus 2x is 0, right? Is that right? A minus 4x squared minus a minus 4x squared is 0. When you subtract that second minus 4x squared, doesn't that make it a positive? Everybody agree? And then a minus, let's see, minus 4x squared minus a minus 4x squared is equal to minus 4x squared plus 4x squared, which is equal to 0. That's where the 0 came from. Now, the next one is minus x minus a minus 6x is minus x plus 6x, which is 5x. Everybody agree? Everybody agree? So now I have 5x plus 3.
No, it'd be minus 3, don't you just drop it down?
Yes. Thank you, Jake. Shame on me for saying you forgot. Okay? Now, can I make x squared into, remember I only look at the first term, right? Can I make x squared into 5x? Not without a fraction.
Yeah.
The obvious answer is yes. I'd multiply it by 5 over x, wouldn't I? Wouldn't that get it? But we're not talking about making more divisions. I want you to say, I can't make x squared into 5x. So now I think that, and I'm going to write it, I think that 2x cubed minus 4x squared minus x minus 3 over, jeez. Isn't that the way you wrote a remainder? Didn't you, in the 3rd grade, when you had some number left over down here, wasn't it the remainder? And don't you write it as a fraction, that remainder divided by that? And then one more step. Do you agree? And then wouldn't you agree that I is equal to the integral of 2x plus 5x minus 3 over x minus 3 times x plus 1 dx. Is that correct? You look like death warmed over. Okay? Everybody okay? Now, I think that is equal to the integral of 2x dx plus the integral which I think is equal to x squared plus I1. Do you agree? So do you see what we did? We chopped that baby down to size, didn't we? And we made it a much easier problem to work with, didn't we? So now, they did. That didn't work out too good, did it? Was it 5x minus 3? Any chance that I could have just recopied it in the time I took doing all of that? But now you know what to do, don't you? Hadn't we been doing that all along? So I take 5x minus 3 over x minus 3 times x plus 1 is equal to a over x minus 3 plus b over x plus 1. So isn't 5x minus 3 equal to a times x plus 1 plus b times x minus 3? Is that right? So I'll let x be equal to -1, and I have minus 5 minus 3, that's minus 8, is equal to a times 0 plus, and then this is minus 4b, or b is equal to 2. Then I let x be equal to 3, and I get 15 minus 3 is 12, is equal to a times 4 plus b times 0, which says that a is equal to 3. And aren't we just about there? I1 is equal to the integral of 3 over x minus 3 dx plus the integral of 2 over x plus 1 dx, which is 3 log x minus 3 plus 2 log x plus 1. Everybody agree? And now I is equal to 2x, right? The 2x we got from long division, plus 3 log x minus 3 plus 2 log x plus 1 plus c.
That 2x should be an x squared.
X squared. We integrated to it.
You took the
You're
integral
gonna take the
after long division. Yeah, it's x squared. 2x at the beginning is x squared.
Oh, I was doing it by memory, and I remembered wrong. X squared, thank you. It ends Spencer. Pretty cool, huh? And whatever else, wouldn't you say that it sure made the calculus easier? You may not have liked the long division, but it did make the calculus easier, huh? Ed?
Yeah, I want to encourage everybody to get some help from me or Dr. Hitchcock, because what happened last semester, at the speed you were going, people didn't have time to master this, find the A, the B, and the C.
He's right. You know, it started off looking so easy, But do you notice that we've slowly made it more and more complicated? And I'm not through making it look complicated yet. But you gotta admit, the whole concept beats string substitutions, huh? Byers likes to use synthetic division. Anybody else here like to use it?
What is it?
You strip off the coefficients of each, and I'd say that you just work with the coefficients instead of writing it out as long division. If at this date, if you haven't seen it before, it's one of those things, just forget until somebody has time to sit down and show you. And that somebody will be me, but I confess to you, I don't use it often enough. And there's a place where you change the signs, and I forget the place to do it sometimes, so I just use long division, and it served me well.
Sounds like Byers likes stuff.
It's a lot easier, isn't it, Byers, if you feel comfortable with it.
But don't you have to have a coefficient of 1 with your highest exposure?
Yeah, there's some caveats in there, and rather than remember all of that, I just use long division. Questions, anybody? Okay, this is a good place to stop. Let's see, let's talk about this. That was, you got a test Wednesday and Thursday on 8-5. You can take the table of integrals, your calculator, and a 3x5 card with you to the test. Okay? Then next week is the final exam. And next week it'll be on 8-2, 3, 4, and 6. And I'm going to probably finish 8-4 on Wednesday and do 8-6 on Friday and Monday, and then the final exam on those sections.
So 8-5 is just test 4?
8-5 is test 5.
Yeah, test
I call
5,
it
but
test five.
it's gonna be our fourth.
Okay.
That's what's
Alright.
Questions? And it's just 5 integrals using the table of integrals. One of them is a hyperbolic function, but all that means is you go to the section of the table of integrals that says hyperbolics, right? Okay, see you Wednesday. And then Cal 2 starts on Friday the 13th, I think.
Calculus 3?
Yeah, Cal 3. Nobody in here would be interested in when Cal 2 starts. I think some of you that were teetering on the brink took yourself off the brink.
Yay.
And I don't think anybody else. You do, remember what I told you, last time I had 500s on test 5, and the class average was 80. You get one of those hundreds and you'll